We need the quantum computers to be very big. How big? With millions of qubits.
Israel's building a supercomputer. Israel's building a quantum computer. What's the difference between the two?
Supercomputer is based on classical computers. I met a guy, very smart guy, that convinced me that this idea has no future. The basic technology that we develop in Quantum Source is based on a research done in Weizmann Institute of Science in Rehovot by Professor Barak Dayan.
And Naftali Bennett is on your board, right? The former prime minister. Why did you reach out to him to be on the board? And what benefit is there in having a politician on the board? Welcome to another episode of Israel Tech. I'm excited to have here Oded Melamed, the CEO of Quantum Source. But before we begin, make sure you hit like and subscribe, and of course, leave a comment. Why? Because we're trying to make an impact and we want to bring you along with it. You love our content, and so does the world, but they don't know about it. So that's why make sure to give us a 5-star rating on Apple and on Spotify and share with your friends. Oded, thank you so much for being on Israel Tech. How are you today?
Good morning.
Good morning, right? So the first thing I just wanted to kind of jump into is quantum. It's a big word to a lot of people. It scares them. Maybe it's the Q. I don't know. But what is it about quantum you think that people is hard for them to grasp? Because even people that read up on technology, such as myself, I feel like without having a proper conversation of an expert, as much as I read, I really don't understand it.
So I think what makes people scared about quantum computers is that they don't understand it.
Right. Okay.
It's so different compared to classical computers that it's very hard to imagine what type of machines those are going to be and what the impact they can bring to the world. And also the fact that it all based on particles, on quantum particles, atoms, ions, photons. It's too difficult to understand.
See, so you already lost us.
Yes.
So let's do the typical, if you were to explain this to my grandmother, how would you explain it?
To your grandmother?
Yeah. Well, she's dead, but yeah.
It's tough. Quantum computers are machines that utilize the power of quantum mechanics to do calculations that classical computers just cannot. And quantum computers are doing that by using special elements, which are called qubits, very different from bits. And those qubits are, you can imagine qubits like a ball. And each and every moment, the state of the ball is determined the qubit state, and the balls are also talking with each other. So that's quantum computer.
Got it. Okay. Well, I'll pretend I got it. Why can't regular computers do this? What is the underlying technology that differentiates quantum computing from other computing?
The underlying difference is that the entanglement or the connection between the qubits, so they're talking with each other during computation. That's one thing. And second thing, the qubits themselves are not just 0 or 1. They can be in a state which is 0 and 1.
Oh, God. Okay. So explain to us why, if it's not binary, then I guess how does it properly communicate?
So again, imagine a ball. And each and every moment you can be on the surface of the ball in each and every point on the surface. When you measure the qubits, the state falls either to the North Pole or to the South Pole. That's 0 or 1. But until you do the measurement, you can be anywhere on the surface of the ball. So that's the qubit. Now imagine many, many such balls near each other, and they are also communicating with each other. So if one ball is changing its state, it will impact all the rest of the balls in the system. Mm-hmm. So you can think about quantum computer as a machine that can run many, many states at a given time. This is why if you want to break, for example, RSA code, using classical computer, you need to go through infinite number of attempts to break the code. With quantum computer, you can actually test many or almost infinite number of states in a given time.
Before we continue, let me tell you about our partner, Deal. As you know, I'm an entrepreneur. One of the hardest parts of being an entrepreneur is hiring the talent that you need, onboarding them, getting them the equipment that they need, and getting them paid. It's annoying. Compliance is difficult, and there's a lot of different laws in different markets. And most HR platforms, they're difficult to use. Deal is different. It's perfect for founders and startups like me, and grows with you as you scale. Imagine HR, IT, and payroll all in one place, easy to use, and AI native. They take care of compliance so you can focus on your business. And you'll like using it. Go ahead and see for yourself. Visit our partner at deal.com/IsraelTech. That's DEEL.com/IsraelTech. And now, back to the show. Any ball or any touchboard, any part of the quantum computing affects and changes everything else, and every ball communicates with every single other ball.
Yes.
Okay, got it. So let's talk about what that actually means on the hardware, on the physical technology, right? I took a screenshot, but I threw my phone over there. Oh, well. On your website, you talk about having you have single atoms on photonic chips, and then you use all of these words that anyone, even if you're in tech but not in quantum, you're like, what did I just read? So why does it matter to have a single atom on a photonic chip? What does that mean? And what does it matter? Why does it need to be single?
Okay, so we need to go back a little bit. So the promise of quantum computers is huge. So people anticipated.
What is the promise?
People anticipate that quantum computing will contribute more than $1 trillion to the world economy by making significant impact on domains like drug development, cybersecurity, AI processing, financial services, optimization problems, and many others. However, in order to unlock this huge potential of quantum computers, we need computers which are very different from the computers that are available today. The quantum computers available today are relatively small, with maybe hundreds of qubits, those small balls that I described before. And in order to make quantum computers really useful and have significant market value, we need the quantum computers to be very big. How big? With millions of qubits. And the largest quantum computer today has several hundreds of qubits, and we need millions of qubits. So to bridge this gap, we need different technologies, different architectures, and this is what we are focused on. One of the best routes to achieve large-scale computers is by using photonic qubits. So the qubits that we...
Well, I want to tell us what that is first.
What's that?
What is photonic?
Photonics is... Photons are the particles of light, right?
This, by the way, is bringing me back to high school.
Yeah.
Science. I should have paid closer attention.
So photons are measuring units of energy. Those are the smallest units of energy of light. And we are using single photons in order to describe this ball, this qubit. The problem with photonic quantum computation, however, although it can scale up to millions of qubits, which is what is needed, is with current technologies that other people are developing, the generation method to create the qubit, the single photons, and to create the interaction, the entanglement between the qubits, is done using probabilistic processes with a very low probability of success. So just in order to generate few qubits that can interact with each other, we need millions of attempts. This is why the machines that people are building are huge, very expensive, will consume power consumption like a small city, and will require a size of a few football courts just to accommodate the quantum computer. And we found a way. That's what we do, and this is why we use single atoms. We found a way to generate those qubits and to create the interaction between them, not using probabilistic processes, but using a deterministic process.
But how? I mean, that radically changes everything, right? If it's deterministic, doesn't that mean, if I understand correctly, it would take less processing, less time, less energy. I would assume just the resources would just drop tremendously, right?
Exactly. So that's the importance.
So even quantum computing that takes so much energy. So you're taking quantum computing and then you're taking the big element, the big expense, the big headache, the amount of the infrastructure, and everything is something that can technically go wrong. You're taking much of that out.
Yes. So if we are successful, and we will be successful, we can shrink down the huge machine that I just described to a machine that can be accommodated here.
Oh, wow. Okay,
the
cool.
standard server room. will not require any special infrastructure in order to operate it.
Mm-hmm.
So the benefit is huge. However, the technology is super difficult, super complex, and we are the only guys on Earth that develop such a technology.
That's awesome. Okay, now you got me curious about, right, you're saying it could fit in a server room. We could just put it here in the corner. If I were able to get one for my house, sure, it's not cheap. How can one use it in their personal life, assuming that they have no limitation in expenses? Is it, or is it only really for processing for R&D, for technology and big businesses and governments?
Initially, quantum computers will be used by big corporates, governments, for applications which require tremendous computation power. And I think that in your house, you don't need such.
All right, not yet. I don't know.
No.
Things get tough sometimes. So you talk about all the space that's needed for quantum. Now, one of the things I found interesting is the kind of companies that found themselves outside of Gush Dan. You're in Nest Siona.
Yeah.
Why are you guys there? Does that have to do because of, let's say, the space or the energy or things that's needed that might be cheaper, easier? Or what brings you out there?
So the basic technology that we develop in Quantum Source is based on a research done in Weizmann Institute of Science in Rehovot by Professor Barak Dayan. So initially, when we started the company, we had to have our facilities and labs very close to the Weizmann Institute. So we are 5 minutes drive from Weizmann Institute, and that was one of the main criteria. On top of that, about more than 50% of our employees are PhDs in physics, mathematics, computer science.
Wait, are you a PhD?
No.
I love that. It says always say the A students works for the C student.
Yes. My job in the company is to make sure that the coffee is there.
Uh-huh.
The office is clean,
and
we have enough money to pay.
You know what? It's a lot more stress than people think. That's why people prefer to get the PhD.
So we are talking about employees which are usually older than the regular startup here in Tel Aviv.
Mm-hmm.
So I think it's also more comfortable for employees to work in a place which is not at the heart of Gush Dan.
It's harder for them, or no?
It's easier for them.
It's easier because from where you're recruiting from. Yeah, that makes sense. Other than the talent, are there any advantages of being out there?
It's nicer.
It's nicer.
Quieter.
I agree with that. Yeah, quieter. People. I was speaking to someone a couple of years ago, and she was saying, I don't remember where she moved, where she worked to. It was in Petah Tikva. Mm-hmm. And she goes, I'm an adult now. I work in Petah Tikva. And
I was born in Petah Tikva.
You're born in Petah Tikva. So, you're born an adult. Yeah. And then there was something about it. It's like eventually supposed to like mature. The companies are more mature. The lifestyle, the people there, the people you work with. The energy. It's a whole nother vibe. Yeah, working out of the big city, so to speak. So I do like that. Let's talk about actually your previous company, which I think is interesting. And then I want to come back to more quantum stuff. You worked for a semiconductor company called Altair. Full disclosure, I used to do their SEO while you were a CEO, but we never spoke. But so we used to do the SEO there. And what did you do there that I feel like there's some synergy or exposure to information or networks that helped you go from Altair Semiconductors to Quantum Source?
I think it's the experience of building something big. We started Altair as 3 founders. And when we sold the company to Sony in 2016, we were about 200 employees with tens of millions of dollars of revenue. So bringing idea to maturity to the market is something that I learned over the years. And I think that this is what I want to do here in Quantum Source, to bring idea, very complex idea, into the market to make the impact.
Mm-hmm. So, but then why did you start a quantum computing company? I mean,
that's an interesting story.
Because I feel like it's a big leap.
So Altair was acquired by Sony. It's a Japanese company. Mm-hmm. So I spend a lot of time, as you can imagine, on airplanes, hearing podcasts and stories.
Like Israel Tech.
Like Israel Tech. And I remember it like today, flight from Tokyo to Frankfurt. I heard a story about quantum computation. And it was the first time for me to really hear about the potential, the challenge. It got me super interested. So I came back to Israel and started to read about quantum computation. And at that time, it was 2018, before I left Altair, that I met a professor in Weizmann Institute that explained to me about the work that he is doing on quantum computation. So I decided that this is what I want to do. So I left Altair in 2019, wanted to start a company in that domain. I got a term sheet from 3 investors to establish a company based on this concept. And then during my own research and exploration about potential resources to recruit to the company, I met a guy, very smart guy, that convinced me that this idea has no future. And it has no future because the ability to scale up the quantum computer based on that specific technology was not there. So I decided to give up. I told the investors that I don't want to continue. They were really surprised. And I got back home to rest, my pension.
Your pension, yes.
And about a year after, 3 guys came to my house. Gil Semo, which is my partner now, which I know from the semiconductor industry. He was part of Apple management in Israel. Dan Harash, which was the CEO and co-founder of Provigent, which was acquired by Broadcom. And they brought a guy that I didn't know, Professor Barak Dayan. And they told me, well, we have an idea about quantum computation, a radical idea. And we heard that you played with the idea of establishing quantum computing company. We want to hear your advice. Who are the investors we should approach? How to build such a company? And I helped them. Slowly but surely, I got in love with the idea. I got in love with the concept they explained. And I decided to join them. And we decided together to establish a company to bring this idea into life. So that's the story behind Quantum Source.
Amazing. Wow. What was it? Back to Sony for a minute, or Altair. What's it like to be acquired by a Japanese company? I think that's very different. I mean, we've had a Cybele and they're acquired by LG, which are Korean. What's the cultural difference like?
Very different.
Yeah, no, because the Japanese have the most outlier culture in the world by every measure. Israel also has an outlier culture, but not like Japan. And they're so different there. How does that even work? I'd be intimidated to go to a business meeting with Japanese counterparts.
So my experience working with the Japanese started way before we have been acquired by Sony. I started my career after finishing the army in a startup company called Libit Signal Processing. And in Libit, I was responsible for one of the biggest customer of Libit, which was Toshiba, a Japanese customer. So for me, that was the first time to work with the Japanese. And along the years, I realized that Japanese are the best business partners you can ever have.
Why?
If you get their trust, and it takes a lot of time, a lot of effort, but if you get their trust, they are your friends and customers forever.
Right.
Forever.
They're big on loyalty there, huh?
Yes. I love working with Japanese.
Mm-hmm.
After the acquisition, Sony decided to keep Altair as a separate unit, a separate business entity, which was very good for us because we can just keep doing what we always do. Mm-hmm. So that was good. Mm-hmm. However, there are some challenges working with the Japanese. They are pushing us to perfection. And for Israelis, this is sometimes very, very difficult.
I wonder if there's like a Japanese podcast out there, business, and someone's doing business with Israelis and they're asking like the same question. They're like, so what's it like to work with Israelis? And I wonder what that conversation's like. What do you think they would say? Like if they were to say like what's it like to work with Israelis?
They would say that we are unorganized, unpredictable, wild, but smart, and can deliver.
You know what? That actually sounds pretty accurate.
Yeah.
Because I feel like if, let's say we asked an American counterpart, they wouldn't say those things because from the American perspective, it would be a little bit different. Mm-hmm. Yeah. But the unpredictable part, I think, is what keeps things fun. It's a lot of fun here. if a predictable life is a boring life, is one not living, one void of adventure. So, I mean, you succeeded with all. Why did you leave then?
Before we continue, let me tell you about our partners, The Recruitery. The Recruitery places go-to-market talent for early and growth stage cybersecurity companies. The Recruitery specializes in recruiting and retaining top talent in global markets. If you're looking for a recruitment company to help your cybersecurity company close cultural gaps and find great talent on the ground that can help you scale, we recommend you also partnering with our partner, The Recruitery. And now, back to the show.
So I felt after 3 years that the integration within Sony completed, and I need to move to the next step in my career and also leave some room to others to grow within the organization.
That's nice. You say that now, but
Yeah,
sure, I'm sure that.
But that's true.
I know. Just do after the part. I want to go back to quantum, if we could. What is quantum error correction?
Okay. So remember the balls?
Yeah.
And you remember the point on the ball that...
the unlimited points, yes.
The unlimited points. Now, the quantum particles, the balls, are susceptible to noise. Noise that are coming from environment, coming from adjacent qubits. They're very susceptible to noise.
If they're even being, let's say not noise, but if there's any energy else there, any change in energy, you put something else physical in the room, will it change?
Depends on the type of qubits.
Because
So if your qubit is like an atom, yes. If your qubit is a photon-less, it depends on the qubit modality. So if you imagine this point on the ball, it can move. It can move due to noise coming from the environment. So, and that's not good because we want the computation to be very precise. So in order to correct the noise that are coming from the environment, we need to employ error correction, like we are doing in regular classical communication channels. However, employing quantum error correction is super difficult compared to the classical world. And also it requires a lot of overhead, which is super significant. For example, to have like a perfect qubit, super corrected, with error rate which is 10 to minus 15, which is what you have in your classical computer, you need about 1,000 physical qubits just to encode one perfect qubit. So this is the overhead that is required, about between 1,000 to even 10,000, depends on the error model. This is roughly the factor that is needed between physical qubits to the perfect qubits.
Mm-hmm. I was thinking when you were talking about, the three partners that came and tried to pitch you to join them, and they had this radical idea, and they thought how are they so confident it would be successful without actually doing proper testing? Because it seems so complicated, so much overhead, so much testing, so much time, and then, of course, making corrections along the way. How are they so confident?
So first, they were not so confident.
Okay. You made them sound confident.
But when they decided to move forward to establish a company, it was after a year and a half of extensive simulations, lab tests. So they came with some certain of confidence that can be done. They were not 100% sure, but they came with a certain amount of confidence. So first, we had to evaluate what they already tested, what they already measured, what they already simulated. Also talk with potential business partners to understand the potential of this technology, whether it's really worth the effort. And the conclusion was sharp. Go do it.
Fascinating. When I think about, I read that Israel's building a supercomputer. Israel's building a quantum computer. What's the difference between the two?
Supercomputer is based on classical computers. It's very, very strong, but it's still based on classical computation.
So was it just computes at like a much faster?
Much faster.
Just much faster.
Yeah. And quantum computers will do things that even the strongest supercomputer on Earth will never be able to run. So it's a different type of machine, different type of a beast. And Sometimes people are asking me whether quantum computers will replace the supercomputers. No, they will work side by side.
Mm-hmm.
So the supercomputer or even regular classical computer will run certain algorithm, will reach to a point where there is an algorithm that quantum computer can excel and do it much, much faster, or even classical computer cannot do it at all. Move this algorithm to the quantum computer, get the answer, and continue. So they will work hand in hand.
Fascinating. And what does that mean? Like, if you can process faster and better, well, faster would be supercomputer. Quantum, I guess it's a leap. What does that mean for the tech ecosystem or the business or the government? Like, what does that mean nationally?
I think quantum computers can be viewed like a strategic asset to any nation. The first nation that will own a real quantum computer with all the capabilities, with all the error correction, with the size that is needed to run super interesting algorithms, will have advantage over its rival or even advantage over its friends. That's
no longer friends. How to lose a friend.
That's a strategic asset. Once one nation will own such a machine, do you think that it will give access to all the nations in the world?
No, that's why I said they're no longer friends once you break through, you know. Before we get, like, what countries are on track?
I think that the US is leading the race.
Mm-hmm.
China is also making huge progress with huge investments by the government.
Mm-hmm.
European countries are also pouring a lot of money into the domain.
Mm-hmm.
And in Israel, we are modest.
That's so un-Israeli. I don't think the Japanese would say we're modest. Why are we so modest?
Modest in terms of investments.
I got it. Okay, so we're cheap.
We're cheap.
Thank you. Okay, yeah. Okay, we'll get down to everything for you in this podcast. Why are we so cheap about quantum? I think I know why, by the way. I'm going to give my opinion first, and then tell me what you think. I've been, especially since October 7th, what I've seen a lot more of, Israelis are very emotional, and they're actually not long-term strategic thinkers. Sorry, I take that back. They have the capacity, and they do, but they're very much overthinking about the immediate. Everything's very much, the culture is now. So we have a revolutionary kind of aspect of our culture, our politics, our business. That's why we're able to break things. Things that take a lot more discipline, a lot more investments, a lot more over time. I think you're seeing some that there's more investment in deep tech in Israel. So I think we'll be improving over the next generation. It's difficult for Israelis to have that discipline of investing over time, knowing, because we want instant gratification more than anyone. Mm-hmm. You know, we're not willing to think long term.
Yeah, I think that's a part of it. And the second part is that quantum computing in general, all over the world, requires private investment, but also significant government support because of the long-term vision, because of the time it will take to materialize and productize those systems.
Right.
So the government support is crucial. And look what's going on over the last several years. The money is going to other directions.
Yeah. By the way, I love this. You ask any Israeli what they think of. It's probably true for any democracy. You ask any citizen how you feel, how your government's spending your tax dollars, and no one's ever happy, which is just an interesting thing.
I'm not happy.
Yeah, I know, neither am I. I pay a lot of taxes. I pay a lot of taxes in America too. But do you think that the government really just is ignorant? Because I find that, like, I speak to people, well, the government, whatever that means, but the ones making the decisions, you know, in Israeli politics, especially parliamentary politics, those that have, let's say, the power and the budgets are people that lead parties or senior politicians. They don't know crap about this. They don't care. It doesn't help their career. It's too long term. Their instant gratification is get reelected or, you know, make the party base happy or whatever it is. One of the downsides, I guess, of democracy, if you want to say. How do you think people in the government would even be receptive to this such long-term investment if there's really nothing in it for them? Like, even to say, hey, I helped support this or led this, that only happen years later, probably once they're already out of office.
So luckily we have the Israeli Innovation Authority that is really thinking long-term.
Which you can watch in Israel Tech, which we had a...
Okay, good. And we got support from them from day one. I wish they had more budget
Yeah, right.
to be allocated to this domain.
Is that, but how do they just, what do they get? Like, I think their budget is $500 million a year, I think, or something like that.
I don't know.
Okay. How do they decide? Why aren't they putting more into quantum?
I think that it's determined as part of their strategy. What is the portion to be allocated to quantum? And I don't think it's big enough. That's one area to get funding from government. And second is the Defense Ministry, which is also thinking about quantum computing as a way to improve some of the things that are important for our national security. Again, I wish that the Israeli government would put more money in this domain like other countries are doing.
Yeah, we all would. Is this on the radar in the government?
I think so.
When I said the government, who did you think I was referring to? Or like what department or industry? The Innovation Authority or?
The Ministry of Economy.
Economy, yeah. Mm-hmm.
Ministry of Defense, Ministry of Economy.
What about Ministry of Finance?
Yes.
Also. But they know. And they're just not prioritizing. That's really frustrating, isn't it?
Yes, it is.
Right, especially because you're so dependent on the government. That sounds depressing, being dependent on the government.
So luckily we have very strong investors, private investors.
Who are your investors?
U.S. investors, U.S. VCs, as well as Israeli VCs. Mm-hmm. It's a combination. We raised so far $77 million.
Nice.
So only small percentage of our budget is coming from the government. Mm-hmm. Again, I wish it was more, but luckily we have a strong private backup.
That's good. Do you think there's a lot of good players in quantum? Do you think there's a growing industry in Israel?
Yeah, when we started, we were the first and only company that are doing the actual core quantum computing stuff. When we were established, there were quantum machines, which are doing the control system, Classic, which is doing software and operating system for quantum computers. But we were the first that actually were doing the quantum computer, and now there are many more. Mm-hmm. So the ecosystem is growing. The appetite for entrepreneurs to have something which is very long-term, fascinating, but very, very long-term is growing. So it's good.
What is it about entrepreneurs that makes them be more interested in something that's very long-term like that? Because usually we think in terms of exits.
So many of the entrepreneurs in this domain are physicists.
Oh, okay. The mature ones, like we were saying, right? The ones that live in Rehovot and Ness Tziona and Petach Tikva.
And for them, it's like a dream that comes true, to do actually, to touch the quantum elements, to touch the basic of physics. So
right.
For them, it's like a dream.
All right. They'd love to work there. That's a good point. Yeah. You see that a lot. How is it being used in the military? I'm wondering maybe like people that are involved in using it in the Army, right? When they're 18 to 21, when they serve, would they be able to like maybe leave and be involved in quantum or start a startup in a sense like they may do in cyber or fintech or other
Yeah, I don't
domains?
think so.
No. It needs to come from the PhDs, you're saying.
Yeah.
Like AI is also a lot from PhDs.
I think it's even more complicated. You need the maturity, you need the academic background. So it's not the 18 years old guys that are doing something in the army and go out and open a company. It's not.
Would you say Israelis mature well? Because I'm thinking like long term, like, you know, we all mature, me less, but like, I'm just wondering how that plays out.
I don't know.
We're like, are we culturally fit for quantum? You know, that's what I'm thinking.
I think that if you are collecting the right people, the mature ones, those that can really think long, those that are not afraid of very, very difficult problems that arise every day.
Right.
And sometimes there is no solution for the problem. So you need to look for workarounds and maybe different directions. It's not a pure engineering task.
Right.
It involves a lot of deep science. So it requires a different set of people.
Mm-hmm. When we were talking about the government being supportive or not as supportive as you would like them to be, let's say, Naftali Bennett is on your board, right? The former prime minister. Why did you reach out to him to be, or did he reach out to you? Why did you reach out to him to be on the board? And what benefit is there in having a politician on the board?
So as part of the board, Naftali is not a politician.
Right, I understand that, right. But I even think he gives you insights, maybe how to navigate the government to get more funding or to be able to lobby or, you know, or to raise awareness.
So first, Naftali arrived to our office when we just started. was excited like us by the story, by the potential to the state of Israel if we are successful. I think that he thought that if we are successful, we can put Israel in a different position in this domain, in quantum computation. Naftali also has a lot of background in the high-tech industry. He was himself the CEO and founder of several startups, successful startups. So getting an insight from someone which has experience in startup industry, in high-tech industry, as well as the way governments think, the way big corporation thinks, is super beneficial to the board.
What have you learned since having him on about how governments think?
I learned a lot.
Did you? You know, there's was that Mel Gibson What Women Want, where it's about what women think. It's the whole thing is he hears women. We need a movie like that for government. What government thinks.
So you need to be patient with governments. You need to think about how to present the strategic importance to the nation in order to get support. And also
Connections. Yeah, it's always about the connections. Got it. That relationship bared its fruit, at least in regards to the connections in the government.
With the Israeli government, we don't need any connection because
everyone knows everyone.
Everyone knows everyone. But we got some tips and connections to others.
Mm-hmm. Fascinating. Very cool. Interesting. So before we were filming, I was asking about your personal life. Mm-hmm. And hard to believe, this young man has 2 granddaughters. But you were also saying that your wife is also a CEO.
Yeah.
Of a company,
startup.
Of a startup. What's that like? I was wondering, like, the relationship, because there's so much time and work, and everyone has a crazy schedule. It's unpredictable. Like, you can't even plan. Do you want to go out Tuesday night? You never know.
First, it's interesting because we share common problems.
Right.
So I don't need to explain to my wife why I came home stressed. Because she
also comes home
stressed.
What happens when you both come home stressed?
And,
how do you support each other?
We can share ideas before board meetings and after board meetings.
That's
so
nice.
It's
You're
nice.
someone to bounce ideas off of and all that.
Yeah.
When you're both stressed, how can you be supportive of one another?
Just drink wine.
Okay, great. That's a great idea, by the way. That's a great recommendation. Lovely. I like that. That's probably some of the best tips. I asked a lot of questions on this show, but that's actually how I lost weight a few years ago and kept it off. I replaced dinner with red wine. And so it was just 2 glasses of wine, got tipsy, and for like 300 calories, and that was it. One of the other things I'm trying to understand is how like quantum will be in like a generation from now, 20 years. So now when we hear about quantum, it seems far away and not relatable.
Yeah.
If you were to say the same thing about AI a year ago or 2 years ago, I would say the same thing. AI is now becoming more relatable to the everyday individual. Mm-hmm. Whether they see that in ChatGPT or they see that in autonomous driving, right? And they started, machine learning is probably easier to understand than quantum to the regular individual. Do you think quantum will be part of our everyday life in 20, 30 years? Like, as individuals, I don't just mean as people in tech?
I don't think so.
Okay. Will it be more prevalent? Will it be a term that people will be throwing around more or understanding?
So I think that the major impact of quantum computation on our life will be through other directions. For example, probably quantum computers will enable faster development of new drugs, new medicines, new materials. Will help big corporations to optimize very complex processes much more efficiently. It will change the way we transfer information because of security issues. Mm-hmm. So I don't think it will impact the individuals, but it will impact our lives for sure, but not directly.
Our lives, but not directly. Do you think the term will be more commonly? Do you think we'll see like businesses using quantum technology to create consumer brands or B2C, or you know what I mean? So that you would see like a regular B2C business been like powered by AI, you know what I mean? AI and Tech Incorporated. They don't know how or what that means, but will we maybe see that when it comes to quantum?
I don't know.
No, I feel like quantum is just so out there that I feel like it's always going to be, I hope not, but like unapproachable to the masses.
I think it's very hard to predict the impact of quantum computation on our daily life. Right now we know about certain sets of problems that quantum computer can really do well and excel. And over the years, when they will realize and will materialize, we will see more and more people using quantum computers and find more and more applications. And maybe one day, maybe it will help also B2C.
There you go. Yeah, it will be more. One of the things I try to do is I try to make like technology more accessible and understanding, especially the Israeli tech, of course. And I find quantum the hardest to make accessible, which is why I asked you to explain it to my grandmother.
Does she understand now?
I told you. Oh, no, she's dead. She probably understands better than we do right now. You know, once you cross over to the other side, who knows what you know? But she definitely knows more. What should we expect out of, let's say, Quantum Source in like the next few years?
So our plan is to introduce a large-scale fault-tolerant machine, something that is usable for corporates and governments.
Like an off-the-shelf product, almost, so to speak.
Almost.
Right.
Before the end of the decade.
Okay, cool. Okay, got it. So the next 5 years or 4 years.
Yeah.
Amazing. And then how much do you think that will cost?
To reach to that point?
Yeah.
Probably additional $50 to $100 million.
All right. So we're going to crowdsource our audience. We don't need the government. Screw them. How's fundraising going? Because it's so long term, right?
Yeah, we raised our round less than a year ago. Mm-hmm. We raised $50 million, which should be sufficient for the next several years to reach to the next important scientific milestones. So we are good.
So what's the next milestone you want to hit in order to be able to easily get more funding?
We need to show a working prototype of the basic building block. And that's our plan for the next several years.
And then once we have that, then you're ready to make it into a product and go to market.
Yeah.
That's awesome. Amazing. So you may be hearing not that much out of the next few years, but you will be hearing a lot more about Quantum Source in years to come. Oded, thank you so much for being on Israel Tech. And to stay up to date on everything about quantum and Quantum Source, follow Israel Tech, because this is going to be a long journey. Love what you're doing here for the country, the state of Israel, and of course the technology that we need in order to make a big impact in the world. Thank you, Oded, for joining us.
Thank you.